now we're going to look at example 4. Example 4 says calculate dy dt at the point 0, 5 pi halves on the following curve. Okay, so since this is with respect to t is just going to be treated like x on the previous problems. So once again, it's going to be very similar to the other examples. And the first thing we want to do is take the derivative with respect to t of both sides. Okay, when we do that, we have a product rule right here. So we're going to rewrite the first, then take the derivative of the second. Okay, derivative of cosine is negative sine. Then we're going to rewrite everything that's on the inside. And then because of the chain rule, we're going to multiply everything by the derivative of the inside. So if we take the derivative of y, that's dy dx. If we take the derivative of t, we're going to get a 1. If we take the derivative of t squared, we get 2t. Alright, looks kind of messy, but whatever. Okay, t cubed is just going to be 3t squared on the right. Okay, from here we want to clean things up a little bit. I don't want to rewrite everything though, so I'm just going to say negative y, just kind of distribute that into there. And then from here, we need to isolate dy dx. And so unfortunately, the best way to do that is to distribute all of that into that. Now, we could treat this like this, so we're only distributing twice, and I think that's what I'm going to do. So I have my dy dx, or dt actually. Sorry, I messed up on these. These should be t's. dy dt. And we have negative y sine y plus t squared. And then we have this thing, 1 plus 2t, and then I'm going to rewrite all of this. Negative y sine y plus t squared. And that's still all equal to 3t squared, which I ran out of space. So let's try that. Okay. Now we have all that. And the last thing, as far as the algebra is concerned, we just need to divide both sides by all of this. Oh, no we don't. Never mind. I got ahead of myself. Okay. We want to get dy dt on one side, so I need to first subtract this entire thing. So I'm going to subtract that over here. So I still have dy dt negative y sine y plus t squared. And that's equal to 3t squared minus okay, all of that. Now we want to divide all of this over here, divide all this over here. So all this is gone. So our dy dt is equal to this. And if I remember right, we're just plugging in that point. Is that what it wanted? Calculate dy dt at that point. Yes. So all we need to do is go back to this point and plug in 0 for x and 5 pi halves for y, or 0 for t. Sorry, I keep saying x. So all of my t's are going to go to 0. So 3, 0 squared minus 1 plus 2 times 0, negative, and then we have a y, which is 5 pi halves, sine y is 5 pi halves, plus 0 squared. The bottom, 5 pi halves, negative, and then sine and 5 pi halves, plus 0 squared. Alright, a good thing is a lot of this goes away. So let's go down here, give ourselves some space. Okay, all of that goes away because it just goes to 0. This goes away, and all of that just becomes a negative 1. So I'll rewrite that. Okay, then we still have negative 5 pi halves of sine of 5 pi halves, because all of that goes away. On the bottom, we have negative 5 pi halves of sine of 5 pi halves. And so what's going to happen? So negative 1 times this, it's just going to get rid of those. And so we have 5 pi halves of sine of 5 pi halves over negative 5 pi halves sine of 5 pi halves. So we have essentially something over the opposite of itself. So that's like saying 1 over negative 1, which is just negative 1. If you need additional help, please come to Math Lab. Until then, calculator.